In this video, we're demonstrating the use of Modbus to exchange data between two PLCs, a master PLC and a slave PLC. In this particular exercise, what we're going to be doing in the master PLC is using a Modbus receive command. We're going to be pulling or grabbing data from the slave PLC and bringing it in the form of bits. In the slave PLC, which is slave address number 1, we have no program whatsoever. We simply have an end statement. We do, however, have some hardwired input switches, an X1 switch and an X2. And I can show you the X1 going on and off, see the green light, and the X2 switch going on and off. You can see the green light there. But there's no actual program in this PLC, so this PLC is dumb for all practical purposes. It doesn't do anything, any logic or any intelligence with these switches. However, in the master PLC, what we have is, in addition to the Modbus command, we have an on-delay timer. And that timer has two inputs, one to enable the timer and one to reset the timer. This is a retentive timer, so when the enable input goes low, it holds the current count value and it waits for a reset before it goes to 0. Looking at the Modbus command, we see we're using Modbus function code number 2, which is to read the input bits. And the slave address is, in the slave PLC is X1, so we're going to be using bit X1 in the slave PLC and bringing that over to bit C1 in the master PLC. Now what we're also doing here is we are exchanging not just one bit but 2 bits. So looking at the command in more detail, we're using the Modbus function code number 2. We're starting at the slave address of X1, input X1, starting at the master address C1, reading 2 bits. So the slave PLC's X1 becomes the master PLC's bit C1, and X2 in the slave PLC becomes the master PLC's C2. X2 and C2, X1 and C1. So then over here in the master PLC, we have 2 contacts, a C1 and a C2, that activate the timer. So when this is running, when we push the X1 switch on the slave PLC, the master's timer should begin to time. So go ahead and push that. Let's see if this works. Oh, actually I have to go back to status. One moment, I have to activate status. Download. And back to run mode. Okay, now we're running again. We can see the active count status here. Active count status here on the timer. Go ahead and push the X1 push button switch, and we see the timer begin to increment. 1, 2, 3, 4, 5, 6. Okay, let go of the X1 switch. Being a retentive timer, this holds its value. Now go ahead and push the X2 switch on the slave PLC, and you can see the C2 contact energize. It resets the timer. Once again, push the X1 switch on the slave. You see the C1 contact energize, and the timer begins to count. So we're using Modbus to read the X1 and X2 inputs in the slave PLC and use the statuses of those bits to toggle a couple of internal bits, C1 and C2, in the master PLC to make a timer time.